undersea storms accelerate Antarctic glacier melt, raising sea level concerns underwater storms. Swirling vortices of warm water are significantly accelerating the melting of the Thwaites Glacier in Antarctica, often called the Doomsday Glacier due to its potential to raise global sea levels dramatically if it collapses. New research reveals these previously underestimated forces could be contributing more to ice loss than previously thought. The hidden threat beneath the ice, these aren't storms in the traditional sense, but submesoscale features up to 10 kilometers wide that form when water layers of differing density collide. Similar to hurricanes on the surface, these underwater vortices trap themselves under ice shelves, the floating extensions of glaciers that act as a natural break against rapid ice flow into the ocean. Once trapped, they are nearly unstoppable. The scale of impact is significant. Modeling shows these storms account for approximately 20% of the total melt of the Thwaites and neighboring Pine Island glaciers over a 9-month period. This marks the first study to comprehensively quantify the impact of these underwater storms across an entire ice shelf. How underwater storms work the process is a vicious cycle. Antarctica's water structure has cold, fresh water resting atop warmer, saltier deep water. When a storm becomes lodged under an ice shelf, it draws the warm, deep water upwards, melting the ice from below. The resulting freshwater release then fuels the storm's spin, intensifying the melting process. They have so much motion, and they're really hard to stop, says Mattia Pinelli at the University of California, Irvine. So the only way they could go is just get trapped under the ice. This cycle is already observed elsewhere. In 2022, a research float captured by an eddy under another Antarctic ice tongue measured 0.11 meters of melt annually. The smaller submesoscale storms, now quantified by Pinelli's study, are likely contributing similarly. Why this matters: the Thwaites Glacier is already losing 50 billion tons of ice each year. If it were to collapse entirely, it could raise global sea levels by 65 centimeters. The accelerating melt driven by these underwater storms suggests that current sea level projections may be too conservative. The warming climate is exacerbating the problem. As more freshwater pours off Antarctica, these storms are likely to intensify. The challenge now is to better understand these processes through increased monitoring and observation under ice shelves. As Tiago Dotto at the UK National Oceanography Centre points out, we may be underestimating the role of these small-scale underwater events due to insufficient data. This calls for urgent investment in subice observations to refine our understanding of Antarctic melt rates and prepare for future sea level rise.